Welcome back. Tips for B4, B5 and B6 of assignment 2. So the tutorial questions. So B4, we have a function set of x and y. We have to expand it in the Taylor series around x is pi over 4 and y is pi over 4. So before we set of xy is sinus x sinus y. Now remember, in class we looked at the expansion of f, or in this case z, around x and y. So here we have that x is pi over 4 and then delta x is h, and y is pi over 4 and delta y is k. So that gives us this when we substitute sinus pi over 4 plus k. So then we have the first term. Now we need zx in pi over 4 pi over 4, so dz dx times h plus zy pi over 4 pi over 4 times k, and then the terms with h squared, hk, and k squared, and then the higher order terms. So in the question, the first part is 1 and the second part is 2. So you need to derive zx, partial derivative of z with respect to x, zy, zxx, zxy, which is zyx, and you need to calculate zy. You can do that first, and then you substitute it in the Taylor expansion. And then you evaluate this at all these in pi over 4, for x is pi over 4 and y is pi over 4, so you can use it in the Taylor expansion. So you use that in there, and then you get the desired terms. So you need to know sin pi over 4 and cos pi over 4. Let's look at B5. Use first order conditions to find all the critical points of the 3 given functions. So B5. So what are the steps for all of them? Step 1 is give the function a name. Maybe it's only a function of x and y, so it's x cubed plus y cubed. I think I might have done that one in class, but you calculate fx, fy, and then you equate that to 0, give the relationships a name, and step 2 is solve A and B together to find critical points. You can have more than one. Here there are actually 2 x0, y0. So you find 2 x0, y0. Simplify the relationship, use one of the relationship in the other one, and be careful to follow the combinations. So in 2, it's called 2 gxy is x to the power 4 plus 2x squared y minus 6y cubed. So we need gx, so that's 0, gy. Calculate that, you set that to 0, call this A, call this B. So that's step 1. And then step 2 is solve A and B. Now in this case, it's 4x squared plus y is 0. So that follows from A. So from A we have 2 cases. X is 0, or x squared is y squared, or this is y is plus or minus x. Then use this in B, and then well, you can go both ways. You find you use this, actually you use this in B, and there are 3 critical points here. So B3 is function of, we'll call it a function f x, y, z, or let's call it even a different function, h of x, y, z. What is it? X cubed plus 4xy plus 2y plus 2yz minus z squared. So step 1 is calculate hx, equated to 0. That's relationship A. Calculate dh dy, whatever it is, equated to 0, call that B. Calculate dh dz. My pen is a bit empty. h dz, yes, is 0. That's relation C. Relationships B and C are linear. So B, alright, now we are, it was loose, that's it. B and C are linear in x, y, z, as you will see. So combine and solve. Use in A. You get 2 critical points. So it's always a bit of an art to see which relationship you should start to solve. It's trial and error. One route doesn't work, then try another one. That's the best thing to do. Let's look at, that was B4. B5, right? No, it's not B3, that's B53. Sorry, B53, not B33. Let's look at B6. B6, use the leading principal minus and use the leading principal minus or principal minus to determine the sign properties of the following quadratic forms in 3 variables, y, x, y, z. So for 1, 2, 3, you first write down step 1, write down the matrix A. So for 1, the matrix A is, let's say, well, there's no square terms, so the diagonals are all 0. The 2xy is 2, so that's 1xy, that's another yx, but minus xz, that's minus xz, minus 2xz, it's minus xz here, minus zx there, and then yz is 1yz here, and then 1zy there. So first you calculate the, so that's step 2. Step 2 is calculate the LPMs. So in this case, that's LPM 1, which is the top left corner. So here LPM 1 is 0. Then you calculate the one you want, purple LPM 2. So that's this corner. So LPM, the determinant of that corner, top left 2 by 2 matrix. So that's minus 1. And then you, let's do red. For these 3 by 3, you calculate LPM 3. So that's the determinant of the entire matrix, which is 0. Looks like it's minus 1, so it's minus 2. Minus 2. Is there more? No, that's it. That's it, right? Yeah, that's it. Minus 2. That's less than 0. Less than 0. This is 0. So when 1 is 0, it's either positive semi-definite or negative semi-definite. So, but in this case, it's not. It's negative and not alternating, so it's indefinite. I'm not doing the first one. That wasn't the point. It's okay. So in 2, you do the same. You calculate the LPMs. If one of LPMs, or if I say that incorrectly. If LPM LPM 3 is 0, then you need to look at the principal minus, or principal minus of order 2 and all principal minus of order 1 as well, and then classify. So if all the LPMs are positive, it's positive definite. If LPM 1 is negative, and then LPM 2 is positive, so they're alternating. LPM3 again negative, then it's negative definite, negative semi-definite. LPM3 is 0, and then you need to look at the principal minus of order 2, so PM2, and the principal, which are two of those, and then the principal minus of the 3 principal minus of order 1. Forgetting something.